I hope you all guys are having a very good day. So in this video, we will be going through like how do we solve this problem of when we have two images which are very similar to each other and there are some differences in those images. So how do we solve it using Python language? How do we automate the task? Now before moving to the solution, let's first understand what the problem is and let us go through some of the images ourselves. So just to get an idea of what really are we trying to solve. Now consider this situation here. We have two images, one on the left and one on the right. Again, they are pretty similar to each other, just there are some differences. Now can you spot those differences? Well, let's see. The clouds present here, but they're not here, so that's one difference. Then you also keep looking. Um, yeah, then you can see this round things here on the curtain bar, which are not present in this case. Also the photo frame here it's not there. The color of the pillow, the fruit, here it is 4, here it is 3, and the time of the clock. So these were some of the differences. And obviously, I've gone through these images before as well, so I know what the differences are. Now let us look at another image. This is much easier than the first one. When you find out the difference, one is the apple here, right, and another apple here. So here the color is changed. Here there is no apple. Then I think this is the smoke coming from the window, like inside the house. So that's another difference. The tongue, the tail, the color of this thing, whatever this is called. And then what else? Yeah, the flower here and the grass here. So these are the differences in this image. It was not that difficult. I mean, it hardly took us 10 to 15 seconds to find it all. Let us go towards more complex images. For example, this one. Now, this is a bit hard, right? You can't just look and tell the difference. You have to go through and scan through the image. And just to give you one or two differences, one is this one here. I think here it is an orange, here it is red color, maybe a tomato or an apple. Then this is sunscreen, right? It has the symbol of a sun here, and here it is a moon. I'm not sure why would one require a moon cream, but yeah, the difference. There may be others as well, just I'm not able to find it as of now. Okay, so this is more real world image. Now we can see the difference here. The people here are not present. Here they are. There are some things here which are not in the left hand image. Right, so yeah, we can see spot the differences. Alright, in this one. Okay, you just go through it and see the difference. I will just highlight one or two which I remember. For example, one is the road strip here. It's not present. Then on the back of this man, the color changes. Right. Similarly, there will be others as well. Like I couldn't find it as of now, or I can't remember. All right. Now let's see this one. This is very high dimensional image. It's very real. So can you spot any differences between these two images? Let's zoom in a bit. And I'm pretty much sure this guy is having a very good day. The see his body language. Yeah. So can you see any difference here? Um, if you just see it, can you spot any difference? So there's one difference. So here you can see a timer is there and here there is not. So that is one part. Now what we are trying to do here is automate this thing using Python language. So we feed in the two images, this image and this image, to the Python program, and it tells us the difference, like where are the differences. And one more interesting thing about it is that we will be using very simple image processing techniques. So we won't be doing any deep learning stuff. We won't be training any model, nothing like that. No object detection, just very simple image processing things. And this is the fun part, right? How we can use the simple things to build something that is meaningful. Now, if I go at the directory of it, just give me 1 second. Yeah, so this is how I have the images as of now. So they are already separated. I mean, we have beach underscore a dot png, then the other image would be beach underscore b dot png. Similarly for every others. So this is the data that we have as of now. Now, how do we solve it? Right. So I'm taking this for example. How do we find the difference? Isn't it pretty easy? We just subtract it and we get the difference, right? I mean, this is the first thing that one will try to like the approach that one would try to follow first on. Just take the difference. Oh, what's so fuss about? So let's run this. Let's see how it works out. So we'll import CV2, NumPy, and Matplotlib. CV2 will be used to load an image, perform image operations. NumPy just to play around with matrices, and then to show the image we will use matplotlib.pyplot, and we are importing it as PLT. Now I will read these two images. So this is present in the home directory only. I've taken it out. diff1.png and diff2.png. Maybe I could have thought of a better name, but as of now we will proceed with this one. All right. So now I will load the image, the two images. Now if I need to subtract it, so if I just go ahead and do difference is equals to cv2 dot subtract im1 and im2, well, it works. Difference of shape, yeah. So but the thing is, um, for difference to work, both of the images should have a similar size. Now here it is the case, both of the image do have the similar size, but if not, if let's say this has even 1 pixel more than the width is 1 pixel more than this image, even in that case where the difference between them is the size difference is negligible, even in that case the subtract won't work. So we need to resize it so that they have the different shape. So now what this line does is we first of all check whether they have the different shape or not, and if they have, we make them equal shapes. So now after running this, no matter what the size of im1 im2 are, after running this they will have equal same size. Now let us plot both of them. All right, so again we just need to subtract it, and hopefully when we subtract it we will only be left with the differences. For example, here we will be left with um, the apple, this one, then the tongue, the tail, and the flower, this thing here, and the grass. And all of the rest will be complete black, zero. Now let us see and run it. So when I run it and plot it, this is the result that I get. So yes, there is apple here, there is one apple here, there is the flower here, grass here. Obviously, color. I think it is understandable why the color is different, because it has three channels RGB, and the similar channels they get washed away, and the channel which has the difference it or maybe yeah, no, maybe it was BGR to RGB conversion that we needed. So this command here just converts it to RGB format from BGR format. So what do we observe here? So we observe that that we do have the differences, but in addition to that we have these edges which we don't want. We don't want these. We don't want these outlines. We don't want this thing. But the question is, why are they even here? I mean, they should subtract out, right? We are performing the subtraction. They it should not be even there, right? We only expected the differences to be present in the image that we get after subtraction. Why are these lines or these edges present here? Can you guess why? Well, because for this to work, if we want that, okay, we subtract and we get the result, the two images should be perfectly aligned with each other. That means each pixel should be aligned. And what it means is, um, let us say some pixel here is representing this position here. All right, so we can look here and here, we can get the pixel coordinates. Now the exact same coordinate should represent the exact same region, and in real world it is actually quite difficult. Right. So what I was telling is that in real world it is extremely difficult that we get exactly aligned images. So we need a workaround. We need like a way around this. So how do we solve this issue? We tried the difference, but it didn't work because the images were not aligned. Now how do we solve this issue? Well, let us consider if the images are perfectly aligned. Well, in that case, we take the difference and we take the subtraction and we get the differences here. Now our target is to align the images, because if the images are aligned, then it is an easy task. Now how do we align the images? For that, there is a topic named affine transformation. So what happens is, we take an image, we multiply it by a matrix, so that is a 3 by 3 matrix, or in CV2 it is represented as a 2 by 3 matrix. And when we multiply that, it basically like there is some geometric transformation in the image. Now the idea that we want to implement here is that, so this is the theoretical part, you may skip it if you don't like it, but just to give you an intuition of what we are doing here. So we need to find a matrix such that when we multiply that image with the given matrix, the resultant image will be aligned to this image here. Alright, so how do we do that? So let's skip over to another notebook here. So this is the final result that we will get. So this is my notebook which I created when I was researching on this issue. Right, so all the things that I tried, I mainly doing it in Jupyter Notebook is much easier than doing it in a Python script. I'm in the research part, and once the research is over, then we can move the polished code or the final code to a Python script, and there we can execute it. But while researching, it is like using Jupyter Notebook is much more sorry, so using Jupyter Notebook is much more helpful. Now how do we align the images? Now first thing is that we have done here is converting it into grayscale, because to align the images the colors don't really matter. We can convert it to grayscale and then we can work with that. So the procedure that we will follow is, the first part we will find the key points in the image, and the key points are the points that basically are the area of interest. For example, this head region, the eyes, or right, the nose. For example, this patch here is not a key point because it doesn't involve any change. It has just a fixed color. But when it transitions to an apple here, this is a key point. So the first part is we will find key points in both of the images. Once we have the key points, we will do feature matching, which means which key point here corresponds to the key point here. So if they are similar, we will match them. And using those features, we will calculate or we will estimate the matrix that we can then use for affine transformation and to get an aligned image. So this is the procedure that we will follow. The first is we will create the matcher. We'll have to run it from start. So this 5000 means that we are looking for 5000 key points. The more the better, but 5000 is a good range. Then we compute it using ORB, which is the object here, dot detect and compute. And then to visualize the key points, CV2 has an inbuilt function, so we can use CV2.draw key points to visualize what the key points are, and it gives output as result1, result2, which we can then plot and see what like where the key points are. So you can see the key points. I think you must have already guessed it, how they are computing it. For example, there are no key point here or here or here in the background, but key points are there wherever there is a change, right? So you can see here like this. Then we will match it using matcher.match. So matcher is a object of this class. Now once it is matched, we will sort it by the distance. So here you can see the lines coming from the left hand side to the right hand side. These are the matching key points. And using these matching key points, we will find the affine matrix that we can use for the transformation. So this function, find homography, this gives us the H, which is the matrix that we are looking for. So if we print H here, so it is a 3 by 3 matrix, and this is the transformation matrix, and using this function CV2.wrap perspective, passing in the image, the edge and width and height of the final image, we can get the aligned image. So if I run this, I get this. So now this image is aligned, and obviously if you compare this with the input image, you probably can't notice the difference, because to naked eye, we can't really tell whether the image is aligned or not. So it is very subtle. But we can observe the difference when we do the subtraction operation now, right? So this was the image 1 and image 2 that we had in the starting. And this is the image 1, which is now aligned with respect to the second image. So now to check whether this worked or not, let us take the difference first between this image and this image, which we had already taken, and we saw that these are not giving the perfect differences. And then we will take the difference between the aligned image and the second image, and there we hope to find the difference. But let's see what happens. Okay, so when I run this, so this was the result that I was getting earlier. But now see the interesting thing. Here, when we subtract the aligned images, we only are left with the differences. So isn't it cool? Now we just are with the differences. So this is cool. But now the next step is we need to draw these differences in the original image that was there. Now how do we do that? So first is the obvious method or approach that we can try is just try to get the counters from here, and then like counters has so many functions, inbuilt functions to draw circles over it that we can take leverage of. Now so it is the basic thing. We convert the, so we are taking this image now, we will convert it to grayscale, then threshold it, and then apply find counters, and then plot the counters like that. So I will just go through it. So first of all, converting it to grayscale, because that is required for thresholding. Then we need to threshold, and here I have chosen the threshold value as 20. I have gone through some of them and I found that 20 works well. So this is kind of a hyperparameter, and we actually don't want, we want the solution to be as general as possible. So maybe this is not a good way here. So we need to, like, we will use a different approach later, but as of now this is what I started with. So I thresholded it, and then finding the counters, I got 64 counters. So there were many bits and pieces here and there which were detected as counters, so I needed to remove it. Now, so to remove it, so what I did was I sorted all the counters with respect to their area. So this line here, what it does is it takes all of the counters, and it also takes the area of the counters, and with respect to area, it orders it in descending order. Descending order, which means this here. So first it will be the biggest counter, then second biggest, third biggest, and then continues like this. So now we will just pick the first five counters. So these are the first five counters. So 1, 2, 3, 4. And where is the fifth one? Well, fifth one is here. It is detecting the edge as the counter as well. So this is one thing that we don't want, right? Anyways, so let us see how it looks in the original image, original two images. So you can see the red one are the counters that are detected. So one here. So this was a difference. So that is good. This one is good. This one is also good. This one is also good, but we are missing this and this, and also we are detecting something here, so we need to remove this one. And we know that we are detecting this edge here, so this edge is being detected as a counter, because here it is completely black, here it is a bit gray, so it is also being detected as a counter. So we need to remove the boundary counters, so the counters which are detected at the boundary conditions, we need to remove that. Now I made a function to do that, so it takes a counter and an image. So whatever counter has its center on the very extreme right, extreme left, extreme up, and extreme down will be removed. Alright, so I just need to run a for loop and check the if condition for this. Now let us print it. So now we can see we don't have the boundaries counter, but also we don't have 2 or 3 of the counters not detected, so we don't want that. Now I tried a new method. So what here I did was I took, now the aim of this thing is, like, we have this image here which contains the counters perfectly. The next step is, how do I draw the counters in the original image? And for that I use the get counters method. Sorry, how do I draw the difference in the original image? And for that I used the get counters method. But as we saw that the result was good. I mean, it was progressive, but it was not that good, or it could have been improved further. Now, how do we do that? So for this one, instead of taking grayscale here, so what exactly are we doing in grayscale? We are converting the 3-dimensional image to 1-dimensional, right? And it has a formula, if you know, for grayscale. It is, I think, 0.5 into gray plus 0.2 into blue, something like that. Now, instead of doing that, what I tried was, and I don't have an intuition for it, it just came in my head, and I tried it. So first of all, splitting BGR, and then taking the maximum of the pixels. So when I do that, this is the grayscale image that I have. Now I repeat the same thing. Also now I don't need any hyperparameter here. I will just use 127 as the threshold value. like this one, and I repeat the same process. Basically whatever we did now, we repeat it, and we get something like this. Again, you see we get the boundary, this boundary thing. So we will remove the boundary, and we get this as the output, right? So this makes much more sense. So we now have detected much more differences than earlier, and now we can save it. And so yeah, this is how we this is the final output image. Now we need to evaluate this for all the images that we have. So I just created like a for loop. So we need to create a function, and so just I will go through it. So the final code is something like this. So I have this Python module helper functions.py. It contains two functions. So is border counter, which looks whether a given counter is at the border of the image and returns true or false. Then I have align images function and get top k differences. Now you can go through these functions. Basically these are taken from this notebook only, completely taken from this notebook, nothing new. It's just that the polished version of this, and this is the main function that we will run. So obviously it calls the functions from the helper functions module, and then it runs it. And one another notebook I have here is to run this final code for all the given images, and this is the result that we get. Right, so you can go through the result here and see whether it's working or not. For example, for this image, well, yeah, it is working for this. It is even finding this function, this man here, which I even missed. I don't know what the difference here is or here is. Yeah, here there is a difference of a cap, the strip, maybe some logo on the back of his t-shirt. Right, here also it is detecting many points. Oh, it's missing the clock, but it's getting the cloud, the side of the road, the pillow, the fruit, the Simpsons image. It's pretty less dimensional, so maybe we can, but still it is finding some differences, right? This one, the ribbon, the necklace, I think it was only 3-4 differences, but it finds some additional ones also. I don't think it was there, but because it is very low dimensional, so yeah, I mean, it can happen. Now this one is interesting because we were not able to even manually found the result very easily. So you can see in this case it is able to detect it, so that's a good result. Now I have shared all the link for it in the description, and if you have anything to ask, just let me know. I hope it was useful anyway. So thank you, namaste.